All right. So we've already said that multiplication is repeated addition. Exponents are repeated multiplication. All right. So do we understand if you had 2 plus 2 plus 2 plus 2 plus 2? What's another way of writing that? 2 times 5. I've got 5 of these. So when you have the same thing added to itself repeatedly, that's multiplication. Well, what if you had 2 times 2 times 2 times 2 times 2? So now I'm not adding them, I'm multiplying them. So another way of writing that is 2 to the what? 5th power. So exponents are repeated multiplication. Multiplication is repeated what? Addition. So you can eventually get from exponents down to addition. All right, now, if you ever get confused, you can go back to do it what I call the long way. Now, here's one of your rules. When you have like something to a power times, and I've got the same base. Now, we tend to always kind of glaze over when we see all these letters. So here's what I'm talking about. What if I had 2 to the 3rd times 2 to the 4th? Do you see how the bases are the same? Now, what does 2 to the 3rd mean?
2 3 times.
All right, so 2 times 2 times 2 times, what does 2 to the 4th mean? How many of them do I have?
4.
4. Now, how many do I have in all? 7. So look at your original powers and look at your answer. What's your shortcut? How do you get this power?
You add.
You add them. So as long as your base matches, you can take that exponent and add it to that exponent. So there's you an example of it. Okay. So your example would be 2 to the 3rd times 2 to the 4th equals 2 to the, I add those numbers and I get 2 to the 7. But on a test, if you forgot, couldn't you go back and just figure it out? Now, that's different than this. What if you had a to the n, but it was raised to the m? So what am I going to do? I'm going to multiply those exponents. A to the n times m. Now, think about why that's true. What if you had 2 to the 3rd raised to the 4th? Now, I want to make sure we're clear about this. An exponent only goes with what immediately precedes it. Do you see that what precedes this 3 is that 2? So I have 3 2s, all right? Like we did a minute ago. But what immediately precedes this 4 is the what? The parenthesis. So that means I have 4 of these parentheses, okay? So that's 1 parenthesis, 2 parenthesis, 3 parenthesis, and 4 parenthesis. Now, what does 2 to the 3rd mean? That means I have a 2 times a what? 2 times 2. So in all of these, I have 3 2s. And they're all multiplied. So how many 2s do I end up with? 12. So see, instead of doing all that, it would have been way shorter to just say 2 cubed to the 4th power. I take this power and multiply by that power. And so I do get 2 to the what? 12. You know, 2 to the 7. But if I forget, when do I add them and when do I multiply, just go back to what it means and you should be able to figure it out. All right, look at this one. If you have a to the n over a to the m, let's see if we can find the shortcut. Okay. So do you understand that would be if I had something like this? 2 to the 5th over 2 to the 3rd. The bases still have to match. Now what does 2 to the 5th mean? How many do I have? 5. 2 to the 3rd, I have how many? Don't I have 3? Now let's go back to your property. What's the 2 divided by 2? Isn't that a 1? What's this 2 divided by this 2? A 1. What's that 2 divided by that 2? A 1. So notice what I have. I have a 1 times a 1 times a 1 times a 2 times a 2. So what do I end up with on the top? Don't I have 2 2's? 2 to the second, 4. What's on the bottom? Those are all what? 1s. So I get 2 to the second. So look at this power and that answer. What must I have done? Subtracted. Now it's not big minus small. It's top numerator minus bottom numerator. So let's make sure you understand what I'm saying when I say that.
If the exponent is negative, you turn it into a fraction.
Yeah, we're going to talk about half. Okay? Look what happens if I have this example. What if I had 3 squared over 3 to the 7? I'm going to do it the long way first. And then I'm going to do the shortcut. And those answers have to be the same. Is everybody with me? 3 to the second. Am I multiplying 2's or 3's? 3's. The base tells you what you're multiplying. The numerator tells you, the exponent tells you how many times. So I'm multiplying 3 by itself twice. Here, how many 3's do I have? 7. Now again, 3 divided by 3 is going to be what? 1. And 3 divided by 3 is going to be what? 1. So do we understand that I get a 1 on the top, and what do I have on the bottom? How many 3's do I have? 1, 2, 3, 4, what? 5. So this answer has to be 1 over 3 to the 5th. Now, what if I use my shortcut instead? I would have a 3 to the what? 2 what? Minus 7, wouldn't I? So that'd be 3 to the what? Then these two things have to mean the same. So here's what they write it like a separate rule. Here's what their rule looks like. A to the negative n is 1 over a to the positive n. So this is your example about why that has to be true. So if you've got a negative exponent, it's not considered to be simplified. So in order to make it positive, I've got to move it from numerator to denominator or denominator to numerator. So if my answer ended up being 4 to the negative 2, I don't want you to leave it that way. So how do you make anything a fraction? You put it over what? 1. So if I move it from numerator to denominator, it turns into, I don't change the sign of the base, I change the sign of the exponent. Okay? So, now, it works both ways. If you had a to the negative 2 b cubed, and you had b to the negative 1 a, I don't know, squared, whatever. And they told you to simplify that on your praxis test. Well, the first thing I would do is make all the exponents positive. That seems easiest to me. Okay? How can I make this a negative 2 positive? What have I got to do? Move it where? To the bottom. Now, do I want to move this b cubed? Oh, I don't want to move that one. Now, do I want to move this b to the negative 1? Yeah, because I want to make it positive, so I've got to move it the b to the positive 1. So when you move something from top to bottom or bottom to top, it's going to change the sign. Now, do I need to move this one? No. Now, what do I do when the bases match and I have exponents? What do I do with those exponents? I add them like on number 1. So I get a 4. What am I going to get down here? I'm going to get a what? A 4. Is everybody okay? All right, let me show you this rule, because if I'm doing the praxis and it's multiple choice, they might not have this answer. They might have this answer. If you have an A over a B and it's raised to the nth power, Now, I'm gonna write the rule down and I'm gonna show you why the rule works. That's A to the n over B to the n. That goes with everything inside that parenthesis. Now think about why that would have to be true. Suppose you had 2/7 to the third power. What's that 3? Did it go with the whole parenthesis? So that means I'd have the 2/7 times another 2/7 times another 2 what? 7. So how many 2's do I have? 3. And how many 7's do I have? 3. So they might have this on the praxis, or do you understand they might have this? They might put B over A to the 4. In fact, you know that this is an alternative way of writing what you copy. Okay. Now, we've talked about this before, but let's reiterate it because we needed to use it before. This rule we've already gone over. What's anything to the 0 power as long as the base is not 0? What's anything to the 0 power? 1. Now, look at why that would have to be true. If I had 2 to the third over 2 to the third, right? What is 2 to the third? What's 2 times 2 times 2? Isn't that 8? What's 2 times 2 times 2? Isn't that what? 8. What's 8 divided by 8? 1. Right? Well, now go to your shortcut rule. What do you have to do when the bases match? What do you have to do with those exponents? Don't we have to do what when we're dividing? We have to do what with them? Subtract them. So that would be 2 to the what? 0. See, anything to the 0 power except 0 to the 0's got to be what? 1. So I do expect you to know those power rules over there. Now, we've already talked about multiplication a pretty good bit, so I'm going to kind of leave it, and I want to talk about division for a minute. All right, now this is the part that's going to be a little harder for my Zoom people to see. Okay. We're going to give it a whirl. Okay. I know that you know how to do long division. Okay? But I need you to understand why it works. Now, I'm going to start with a smaller number. What if I had 430, let's do it this way, I like this better. What if I had 736 and I wanted to divide it by 2? Now, you know how to do that. I'm going to go through the standard algorithm with you, but then I'm going to do it with the base 10 blocks, so hopefully the standard algorithm makes more sense because you're going to have to teach it. Do you understand that you're trying to see how many groups of 2 you can pull out of 736? So it could be that you had 736 things and you just kept going. 1, 2, you pull out like hundreds of them. Is everybody with me? Now, the way that you were taught is probably you saw how many 2's you can pull out of 7. Or how many 2's can I pull out of 7? 3. So 3 goes on top of that 7. And then what do you do with these 2 numbers? You multiply back and get 6. You put it right back under there, don't you? Then what do I do? Subtract. And I get a 1. Now, what have you got to double check about this remainder? It's got to be smaller than what? Than that. What if it's not smaller? What does that mean? That you didn't go enough times up here. Like if I did a 2, I would have a 4 and I'd be subtracting and get a 3. Is everybody with me? See, I didn't go enough times. All right. Now, what did you do next when you were doing the standard algorithm? You brought down the next number and got a what? A 13. We'll talk about why in a minute, what you're doing. Then you said, how many twos can I pull out of 13? Which is, you said how many? 6. And then you said 6 times 2 is what? 12, and you got a 1, didn't you? And you double checked to make sure it was smaller. Then what did you do next? You brought down to 6, didn't you? And then you said, how many twos can I pull out of 16? And what did you get? 8. And then there was nothing left over and you were finished. Now here's what I need you to understand. Here's what you're doing. If I could write the number down correctly, that would help. If I want to make this with my base 5 blocks, how many hundreds do I need to have? How many of these flats do I need to have? 7. So I'm going 1, 2, 3, 4, 5, 6, 7. So all I'm doing is taking these and I'm just setting them down somewhere. How many 10s do I need? How many rods? 3. So I get 3 of these rods, and again, I set them next to my flat. And then I need how many of these little cubes? 6. So I count out 1, 2, 3, 4, 5, 6, and those go next to my thing. So on my table, I've got 7 flats, I've got 3 rods, and I've got 6 units, just like you were making with the base 5 blocks. Now, I'm trying to, do I start dividing at the biggest place value or the smallest? I always start with the what? The biggest. All right, so here's what I've got. I've got these 7 flats. I'm trying to pull them out in groups of what? 2. Then you tell me how many times I can do that. Can I pull out 2? So that's once. Can I pull out another 2? So that's how many? Twice. Can I pull out another 2? So how many times can I pull out another 2? No. So how many times did I pull out the 2s from the flats? 3 times. So when I did that, how many flats are now gone? 3 times 2. I took away my 6 flats. How many flats are left? 1. Can I make any more bundles? Can I do any more pulling out on these? No. So what I've got to do is I've got to unbundle this. Now, when I unbundle hundreds, what base am I in? 10. So what's this going to get broken up into? 10 things, right? What am I going to unbundle this into? 10 what? Rods. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, a lot of kids will line them up so that it physically looks like this. Now, didn't I already have some rods a minute ago? How many rods did I have a minute ago? And how many? 3. So here's the 10 that I unbundled, and here's the 3 I have. When I put them together, how many rods do I have? 13. That's what those are. I have 13 rods, 13 10s. Now again, what am I about to do? I'm about to pull out groups of what? 2. All right, so you start marking on your paper every time I pull out a group of 2. All right, here's a group of 2. There's 1. Here's another group of 2. Here's another group of 2. There's another group of 2. There's another group of 2. And there's another group of 2. So how many times did I do that? 6 times. So I removed how many? 12. And sure enough, how many are left? 1. Now see, if I don't go, if I went 5 and I had 10, I have 3 left over, you're going, oh, you can take another one out. So that's how they know when, but they quit when they can't pull out any more of their groups. So I'm left with this. I can't pull out any more of these. That's how I know it's time to unbundle. So I'm going to unbundle this, and how many units do I trade this for? 10. Now, already have how many over here? 6. So sure enough, how many little units do I have? I have how many? 16. And I'm gonna try to pull them out in groups of what? 2. All right, so again, keep track with me. So there's one group of 2. There's another one. There's another one. There's another one. Another one. Another one. Another one. How many we got to so far? How many we got so far? There's another one. Everybody with me? And I keep doing that. How many do I end up pulling out to pull? How many? 8. And are there anything left over then? No. Now, sometimes you have leftovers. I mean, if I had something like 20 and I'm dividing that by 3s. All right, think, how would I make a 20 with the base 10 blocks?
2 rods.
I'd have 2 rods. Now, I've got to be pulling them out in groups of what?
3.
3. Can I pull any out? Can I pull out a group of 3? No, then they need to put a 0 up here. Don't just have them go into the next ones. Everybody with me? Because I don't understand where to put the numbers. So I didn't pull out any rods. I still have 2 left over, but I've got to unbundle. Now again, when I unbundle this one, I'm going to trade it for how many? 10. And when I unbundle this one, I'm going to trade it for 10. So how many little units would I end up with? 20. And how many groups of 3 are they going to be able to remove now?
6.
6. And that's going to give them how many?
18.
And that's going to be what left over? 2. Do they have enough for another bundle? No. So their answer is going to be they have 6, but they have a remainder of what?
2.
So when you're teaching kids long division, you need to teach them on those base 10 blocks. And it's going to take them days and days and days and days and days to do it. Because long division is very hard for them. But at first, all they're doing is they always have the base 10. Everybody with me? And I'm making them do all of this with the blocks. Once they get really good doing it with the blocks, then we'll remove it and they understand why these numbers, when they bring it down, they're unbundling. And it starts to make sense to them. So I know you can do long division, but now hopefully you can teach long division, which are 2 different things. Okay, good deal. Now, they talk about long division in your book. All right. And we've talked about it before. You have division is repeated subtraction. All right. So a lot of times when I'm doing, now understand, you get to division in elementary before you get to long division. So does everybody understand, if you're the 2nd grade teacher, you're probably going to have 12 divided by 3. All right, and you got the you can do the base 10 blocks, you probably got 15 divided by 5. All right, so sometimes what I'll do to emphasize this repeated subtraction, if I've got 15 divided by 5, I'm trying to see how many times I can pull 5 out. So I can pull 5 out there, there's 1. That's going to leave me 10. I can pull out another 5, there's another one, that's going to leave me how many? 5. And I can pull out another 5, you understand, and that's going to leave me what? Nothing. How many times did I color code it so they can, how many times did I pull out 5? 3 times. So I want them to understand, I want you to understand. So if I ask you on a test to demonstrate division using repeated subtraction, that's what I expect you to do. All right, so let's talk about these models for division real quick to make sure we're clear. What do you think the first model is going to be? What's the first model all the time? Set. Okay. So if I do division models, and some of this is already in your notes, the first one's going to be set. So again, if I had 15 divided by 5, all right, I'm going to start with 15 things. And I'm going to divvy it up. So instead of uniting the sets, I'm fixing to pull them apart. Is everybody with me? So I'm going to see how many groups of 5 I end up with. There's one group of 5. There's another group of 5. There's another group of 5. If I union those, you see what I'm saying? I've got 3 sets of what? So this, one of these numbers is either your number of sets or what's in each set. Number in each set and number of sets. Now, couldn't I make it 3 sets and put 5 in each, or I can make 5 sets and put what? 3 in each. So these numbers are interchangeable. Is everybody with me? This one is your repeated subtraction model. Okay. Now, they have what's called a family of facts. Now, let's make sure we understand what a family of facts is. Do kids learn to multiply first or divide first? Which one did you learn to do? You multiply first. Okay. So you might have learned that 2 times 3 is 6. But as soon as you learned 2 times 3 is 6, you didn't just learn one thing, you actually learned 4 things. And they call them a family of facts. Now, here's what, it's not, I'm going to show you, it's not really a model, but I'll label it as a model in a minute because some people call it a model. What would the commutative property of multiplication, if I know that 2 times 3 is 6, if I understand the commutative property of multiplication, what else do I know automatically? That 3 times 2 is 6. Well, some people will call this kind of a model, it's called missing factor. Missing factor model. It'll be something like 6 divided by 2 is something. Because most kids learn to multiply before they learn to divide. Here's what they're doing in their head. They're thinking, what do I multiply 2 by to get 6? Well, what do you multiply 2 by to get 6? 3. So if this answer is 3, what? That answer is 3. So over here, if I know that 3 times 2 is 6 and 2 times 3 is 6, then I know that 6 divided by 2 has to be what? 3, or that 6 divided by 3 has to be what? 2. So they call that a family of facts. Now, you can do the same thing on addition. If you know that 4 plus 6 is 10, you should know 3 other things automatically. What's one of the other 3 things you should know?
10 minus 6.
That 10 minus 6 is what? 4. What else would you automatically know? 6 plus 4 is what? 10. And what other fact would you know? 10 minus 4 is 6. So these are called a family of facts. Addition, subtraction, these are called a family of facts. Now, you got to be careful when you're giving kids a problem on a test. Now, here's what I mean by that. And just because you find something on the internet doesn't mean it's any good. Okay? So Clinton really likes to get these kids to make really high scores on standardized tests. So a lot of times, all through the year, they're giving these kids these standardized, kind of standardized bubble in practice tests. So my son brings one home and he is furious. He said, I got that problem right and she counted it wrong. And I said, let me see. And it said something like this. There are 12 pieces of candy, and you have 4 friends. How many pieces of candy would each friend get? No, it said, think about how many pieces of candy each friend would get. And it said, which operation did you use? And his choices are multiplication, division, addition, and subtraction. So let me repeat the problem. You have 12 pieces of candy and you have 4 friends. How many pieces of candy does each friend get? Now, what do you think the correct answer was? Division. My son put multiplication. And he's right. Any of those 4 answers are right. Because what did he do in his head? He thought, what do I multiply 4 by to get what? 12. So he did use what? Multiplication. Subtraction would be a great answer. I'm going to pull out 4 and pull out 4 and pull out 4. How many times did I do that? Addition would be a great answer. How many times do I have to add 4 to 4 to get 12? So do you see that's a terrible question. Now I understand why the right answer, air quotes, was division, but in reality, they're all right answers when a child articulates how they get it. So I'm sure that teacher pulled that from somewhere and it was a reputable source and she used it, but I had to have a conversation. It's not a good question. It's not a good question. Because a lot of times when you've got students, it's not enough to get them to give you the answer. You got to know, how did you get that answer? And so I've got to make them articulate to me, explain to me how you got that. Why did you write down multiplication? Why did you write down subtraction? Now, sometimes it might be, well, I said 3 times 12, we got 36, and I multiplied. Well, no, that's not working. That time multiplication didn't help you. So do you see, the same answer can be right or wrong depending on how they're thinking and what they're justifying. So I've just got to be real careful with that. Okay. Now, all right, so they kind of show you that at the bottom of page 167, the relationship between all of those. Okay, and we've already talked about all of that. Now, I've never written this on the board. You told me this, but let's make sure it's written in your notes. Oh man, I think I left them upstairs. I'll do it next time. Order of operations. All right, the order that you do things is really important because it changes the answer. Okay? So when I've got a long problem strung out, okay? The order that I do things matters. What's the first thing I do? Parentheses. All right, so the very first thing I do are parentheses. Now, when I say that, I mean like left to right. So, because I may have more than one thing in a parenthesis. Is everybody with me? So I've got to do the first parenthesis I come to first. Okay. Now, once I've got all the parentheses done, what's the next thing I look for? Exponents. Now, we're going to get there later, so I'm going to put roots. Because roots can be written as exponents. Okay? What's the next thing I look for? Multiplication. All right. Multiplication. I'm going to put a slash, I'm going to put division. Do you always multiply before you divide? No, you go left to right, whichever comes first. Okay? Left to right, whichever comes first. So if the division comes first, you do it first. If the multiplication comes first, you do it first. It's whoever gets in line first. And what's the last thing you look for? Addition, subtraction, the same way. Left to right, whichever comes first. You don't always add before you subtract. Now, what I have found is people make less mistakes if they do one thing per line. So look at this one. What's the first thing I do? The what? The parenthesis. Everything else just gets copied. I've got to do 6 minus 1. So what is 6 minus 1 going to get me? That's going to give me 5. That one first. Now I start over on the left. Do I have any more parentheses? So what's the next thing I've got to do? I've got to do X box. All right. So do I have an X box? Yeah, I got one right there. All right. So I got to do that first. So everything else just going to get copied. So I've got 2 minus 3 times 4 minus what? 4. Then I got my plus 5. Everybody okay? So then, how many works supposed what to do next? Multiplication. Now, I'm going to go back and change this problem because we haven't gotten to negatives yet. All right? So do we understand what's the next thing I've got to do? I've got to do this multiplication. So I've got 12 minus, now what is 3 times 4? What's that going to give me? 12. And I just copy everything else down. Now, I always go back to the left. I do one thing per line. So what got in first this time? Subtraction or addition? Subtraction. So I do 12 minus 12. What's that give me? 0. And then I've still got this minus 4 what? Plus 5. Then this subtraction comes first, left to right, so I've got to do it. So 0 minus 4 is going to be a, so we're kind of getting a preview of cunning attractions because I couldn't do this with them yet because that would be negative numbers. And then finally I'm going to get a 1. I can't jump over here in the middle and do 2 squared, jump over here and go, oh, that's a 1, so I'm going to change that to a 1 because I can do that in my head. You can't change that order of operations. Okay? Everybody good? Now, we're going to play a game on Tuesday, but I'm going to kind of explain it to y'all so it'll make sense to you because I left it upstairs and we're out of time. It's called crypto. So what crypto does is it lets the kids play to check their order of operations, but it's way more fun. So what happens is it's a deck of cards, and I'm going to just flip numbers up on the deck. Now, my crypto deck goes from like 1 to like 30 something. But you can do the same thing with a deck of playing cards. Okay? So what happens is this. Let's see. So when I'm first playing crypto with students, I usually will use a regular deck because what I'm going to do is this. You know what numbers are on deck? From 2 to what? To 10. I just pull the numbers out. Everybody with me? And I use the ace as a 1. So what I would do is this. I'd shuffle the deck up. Now you copy these numbers and just write them down real quick and copy them down because this is going to be part of your homework. Okay? All right? Now shuffle them up really good. 7, 1, 1, 10, 9, and then it's a 4. Now look what you have. You have a 7, you have a 1, you have another 1, you have a 10, you have a 9, and then you have a 4. So what you're going to have to do for homework is this problem. We're going to play more next time. You've got to combine these numbers and get this for the answer. So you got to use all of these numbers one time. You can either add, subtract, and multiply, divide, or any of them. You can just add and multiply, or you can subtract, and you can put parentheses and brackets in, but the answer has to be what? 4, and I'll type it in Moodle, and we'll play with it. Okay, so your homework's gonna be in Moodle. You have a great day.
Another video.